So traditional software has got a varieties of definitions. So I need to encapsulate, I need to combine. Only then I will be calling that as a software. Inheriting the property from the base class to the subclass is what we call it as a inheritance. Poly in the sense many. Poly in the sense what? Many. Morphisms in the sense forms. Hello everyone, I welcome all of you to the very beautiful session. In this session, I will be discussing a very interesting topic with all of you. So what is that? Yes, issues in object-oriented testing. So this is what I will be discussing with all of you in this session. So my dear students, so I have the agenda for all of you for this session. So that's going to be these topics. Yes, I will be discussing what exactly units, what exactly inheritance, encapsulation, polymorphism, and also I will be discussing with respect to the GUI data flow testing with respect to the object-oriented testing. All these topics I will be discussing with respect to the object-oriented testing is what you need to remember at this point of time. Yes, guys, let's start the session with the first topic. So what exactly that I have? So guys, units for object-oriented testing is what I will be discussing now. So fine. So let's understand this topic in detail. Traditional software has a variety of definitions for a unit. So if I take a unit, so traditional software has got a varieties of definitions. Let's check one by one what is the definitions for unit. The first definition that I have here is a unit is the smallest software component that can be compiled and executed. That's what you need to remember. It is the smallest component of a software that can be compiled and executed is what I will call it as a unit. So fine, that is the first definition that I have. When it comes to the second definition, whenever I have unit, so please listen here, a unit is a software component that would be never assigned to more than one designer to a developer. What is the meaning of it? If I am designing one unit, only I will be doing it. So more than one developer will not work on that unit is what you need to remember with respect to the unit. So hope you got the clear idea with respect to the unit. Moving forward to the next concept that I have. What is the next topic that I have? Please observe implication of composition. Yes, we have discussed this topic in n number of times in our previous sessions. So what exactly is that? Let's discuss it again. So composition and encapsulation. Let's understand this. Obviously, we all know that composition is the opposite word to the decomposition, right? So we have discussed decomposition and also composition n number of times. Let's understand this with respect to object-oriented testing in this session, right? As I told you already, composition as opposite to the decomposition is a central design strategy in object-oriented software development. Yes, we all know that. So guys, what is the next topic that I have? Next point that I have. So the main implication of composition is that even pursuing very good unit level testing. So guys, what exactly they are trying to say here in this point? Say whenever I'm taking a concept of composition, let me explain that. Let me make this point very simple and easy for all of you. Composition in the sense what? Say for example, I have a main software. Let me assume this is a main software. To have this software, I have to integrate with lot of multiple subsystems and also different units. So I need to encapsulate, I need to combine. Only then I will be calling that as a software. The process of combining or the process of aggregating everything into one is what I will call it as a composition. Yes, we all know that. I don't have to speak about it. You all know about it. What exactly composition? Grouping everything together and calling it as a one is what we call it as a composition, right? Yes. But the main idea that you need to think here is what? When I'm performing the composition, so you need to think more about integration testing. Sir, why sir? Because I will be integrating everything to make it composed. Yes or no? Yes, exactly. So that is what they are trying to explain here. So whenever you're thinking about composition, integration testing plays a very important role is what you need to remember at this point of time. Moving forward to the next point. So guys, what exactly encapsulation is all about? Yes, we understood composition. When we are thinking about composition, integration testing is also Very important. But when it comes to the encapsulation, what is that I need to think? Encapsulation in the sense what? Wrapping up of everything into one single unit. So that is what we call it as a encapsulation. But here, let's understand with respect to this context, what exactly encapsulation is all about. So please listen to me carefully. The rule of encapsulation requires that classes only know about themselves and operates on their own. If I have multiple classes, that class will know only about themselves and they operate on their own. They are not dependent on any other class. So that's what you need to remember with respect to the first point. So fine. What is the second point that I have? A good encapsulation results in the classes that can more easily be composed and tested. What is that? Suppose if I have a good encapsulation, easily whatever the classes that I have in that group, I can test it and I can compose it. So that is what you need to remember with respect to the second point. So guys, we understood that. So what is the rule? So whatever the classes that I have, so that classes are independent. They don't know about any other class and they execute on their own. So, and if I call it as a good encapsulation, you need to remember that what exactly that I need to remember. So it can be easily tested and it can be easily composed. So that is the most important point that you need to remember. Yes, to achieve this is very difficult. So guys, observe the last point that I have on encapsulation. So what exactly I have? Encapsulation has got the potential to resolve this concern, and but only if the units are highly cohesive and very loosely coupled. Only then, so this problem can be resolved. So that's what you need to understand. Hope you all know what exactly highly coupled and cohesive. So guys, moving forward to the next concept. So when I was explaining the most important concept, that is encapsulation, so we remember one of the famous example to explain the concept of encapsulation. So what exactly is that? The famous example is wiper problem. So guys, windshield wiper problem. So what exactly I have here? I have taken three interface classes, that is lever, dial, wiper. So that is class lever, class dial and wiper. So three interface classes is what I have taken. Let me tell you one story to all of you with respect to this so that you will understand that. Okay, so observe this diagram. What happens here? Guys, what exactly the lever is doing? So about this, the dial will not be knowing anything. That is what the first point that you need to remember. Whatever the status of the lever is doing, so that is not known to the dial. What exactly the dial is doing, so that is not known to the lever. But when it comes to the wiper class, so please observe, wiper should know the status of dial as well as the lever. So can I call this wiper class as the main class? Yes, of course I can call this as the main class. So guys, like this, so I want all of you to please assume that, so lever is independent class. Again, dial is also independent class. Whatever I'm doing with the lever is not dependent on the dial. Whatever I'm doing with the dial is not dependent on the lever, but both of them are dependent on the wiper. So I will be setting, so what exactly that I'm doing with the wiper based on these two inputs is what you need to remember. So guys, with the help of this, the conclusion of this, so please remember, this is what you need to understand. A good encapsulation results in the class that are more easily being composed and tested. So this is what you need to remember with respect to this example. Moving forward to the next thing that I have. So guys, implication of inheritance. You all know what exactly the meaning of inheritance. Inheriting the property from the base class to the subclass is what we call it as a inheritance. So now let's understand what exactly the context that I have here. Please remember, the choice of class as a unit seems natural. The choice of class as units seems natural. Yes, of course it is natural. The role of inheritance complicates this choice. So that's the most important point that I need to utter here at this point of time. If I take the class as unit, that will become a problem for me. Why? Please listen to me carefully. If a given class inherits the attributes or operations from the superclass, I have a class, so this class is taking the operations and the attributes from this base class, is what you need to remember. Yes, at that particular point of time, the standalone compilation criteria of a units is sacrificed. So there is a problem. Whenever I have a standalone systems, so that will sacrifice the criteria of units. So that is what you need to remember here. That is a problem. So guys, let's see what happened. So guys, a person, okay, Binder suggests a flattened class. What exactly a flattened class? What exactly a flattened class for this solution? For I have a problem, right? So here, so I'm not able to. So please observe, when I have a standalone compilation, criterion of a unit is sacrificed. So to solve this problem, I have a concept called flattened class. What exactly the flattened class is all about? Let's check what exactly the flattened class is all about now. So guys, listen to me carefully about the flattened class. When it comes to the flattened class, it is a original class expanded to include all the attributes and operations it inherits. Whenever I take anything from the superclass, I will expand that. So that class, I will call it as a flattened class. That's what you need to remember. I repeat this statement for all of you. Flattened class is an original class expanded. So expanded to have the attributes and operations it inherits. So whatever you have inherited, even that you will have. So that is what you need to understand with respect to the flattened class. And it is not dependent on any other class, is what you need to remember, right? The flattened class are mildly analogous to fully flattened data flow diagrams of structured analysis. So guys, I'm talking about the data flow diagram now. So listen to me carefully. I will be speaking about it in the coming slides in detail. Right. Unit testing of flattened class solves the inheritance problem. That's what you need to remember. So you all know that I have a inheritance. Inheritance, let me make it very simple for all of you, whatever I have here. So inheritance in the sense I have the superclass and I have a subclass. I'm taking the properties and operations and attributes from the superclass to the subclass. But I have a problem here. What is the problem? Please observe the problem here. Standalone compilation criteria of a unit is sacrificed. So guys, how do I solve this? So this can be solved by the flattened class. So that's what you need to remember at this point of time. So fine. Guys, now please observe what is it I have. The next point. Flattened class will not be a part of the final system. That's what you need to remember. Flattened class will not be a part of final system. So some uncertainty remains. There is no final solution again. Okay. You said flattened class will solve all your inheritance problem, but flattened class will not be there in your final solution, but still there will be some of the problems remains as it is. So guys, that's what you need to remember here. So guys, you all know that inheritance concept. So this is the base class. I'm inheriting some of the properties to this subclass, and also this subclass is what you need to remember at this point of time, right? Moving forward to the next concept that I have, implication of polymorphism. What is the meaning of polymorphism? Poly in the sense many. Poly in the sense what? Many. Morphisms in the sense forms. One object will have what? How many names? Yes. One name but different forms. That's what you need to remember with respect to the polymorphism. Observe here, the essence of polymorphism is that the same method applies to the different objects. That's what they are trying to say in other words. Same method to a different objects is what you need to remember with respect to the polymorphism. Considering the class as units, so implies that any issues of polymorphism will be covered by the class unit testing. Any issues with respect to the polymorphism, so they will be solving that with respect to the class unit testing. So that's what they are highlighting in the polymorphism. Moving forward to the next, levels of object-oriented testing. When it comes to the levels of object-oriented testing, so mainly we have 4. So please observe, the first one that I have is operation or the methods. Okay, method, class, integration, and system testing. So this is the 4 different levels that I have in the object-oriented testing. So this is going to be very, very important for all of you. So guys, this is what you need to remember with respect to the levels of testing with respect to the object-oriented testing. The next topic that I have is GUI testing. Guys, you all know that GUI testing, in the sense graphical user interface testing. So it's very important that all of us should understand with respect to the graphical user interface testing and how exactly the vulnerability increases and what is the reason behind that. Let me explain that. Listen to me carefully. So guys, GUI are the special cases of event-driven system. So it is a event-driven system, and then event-driven systems are vulnerable to the problems of an infinite number of event sequence. This is one of the major problems that I have with respect to the GUI testing. So guys, I will be discussing about this GUI testing in the coming sessions in detail. So we have a separate chapter on this. All right, so that's what you need to remember. As of now, this is the only topic that you have in this chapter. Moving forward to the next one that I have. So guys, the next one that I have is data flow testing with respect to the object-oriented testing. Listen to me carefully. You all know that data flow testing, when it comes to the data flow testing, how exactly data is being traveling from one part to another part is what we are trying to understand with respect to the data flow. Guys, let's understand what exactly that I have with respect to the data flow testing. Please observe here. The issue of inheritance and composition requires a deeper view. Yes, I have already discussed what exactly the problem that I had with respect to the inheritance when I have two classes. So guys, please observe what is the issue that I have with the inheritance and the composition. This issue requires a deeper view. The emerging conscious in the object-oriented testing community is that some extent of data flow should address this special need. Whatever the issue that I have with respect to the inheritance and the composition, so that this issue will be addressed with the help of the concept called data flow is what you need to remember at this point of time. Moving forward to the next concepts of data flow testing. Listen to me carefully. Data flow testing is based on identifying, defining, and use nodes in the program graph. So we already have discussed some of the concepts with respect to the guys DU path and DD path. I want all of you to please recollect that. So that is the concept that we are using here. So what exactly DU path and what exactly DD path? So that's what you need to remember here. So guys, the same concept is what they are trying to explain here. All right. So fine. Let me not explain that in detail. What exactly DU path and DD path. So please refer my first unit session so you will be able to get. So especially in the data flow testing. So I have discussed this in detail. I want all of you to please go back and check what is that I have discussed about this point. Right. So procedure call in the traditional software complicates this formulation. So I repeat, procedure call in this traditional software complicates this formulation. One common workaround is to embed procedure call into a unit tested. So that's what you need to remember here. What exactly that they are trying to say here? Procedure call in the traditional software complicates this issue. So for that, guys, remember one common workaround is to embed the called procedure into a unit tested. So you are not keeping the procedure call separately. So you are trying to embed that into a unit. So this will solve the problem is what they are trying to say. Right. Moving forward to the next concept. This is going to be very, very important in this session. I want all of you to pay little attention and watch this till the end. What exactly that I have here? Guys, I have example, our familiar next state problem. We have discussed umpteen number of times with respect to the next state problem. What exactly next state problem is all about? So you all know that if I enter any date, automatically it will give me the next date. So with respect to this, I have taken, so guys, some of the important thing that is rewritten here object-oriented style. Whatever I have the next date problem, so I have rewritten that into the object-oriented style. So that's what they are trying to say here. One abstract class calendar unit. Okay. So everything is in the form of classes. Okay. So that's what you need to remember here. All right. So how many different types of classes that I have here? So please observe. I have class number 1, 2, 3, 4, 5. Okay. So fine. So what are the different classes that I have tested? date, day, month, year. So this class deals with this, right? So that's what you need to remember here. And program graph is in the next few slides. So for all these classes, remember, the concept starts now. So yes, we have our next date problem. Yes, we have a next date problem. We have rewritten that into the object-oriented testing concepts. So in that, we have 5 different classes is what you need to remember. So for all the 5 different classes, we have written the graph. We have written the graph is what you need to remember. Let me explain that in detail now. So guys, please, I want all of you to please go through the graph that I have with respect to the date method. I will be coming back to this again. I want all of you to just go through. So guys, you have the tested date dot constructor, date dot increment, date dot print date. So guys, all these things are with related, or this is related to the date. That's what you need to remember. The next concept that I have here is all about, guys, please remember it's with respect to the day methods. So fine, I have day dot constructor, day dot set day, day dot increment, day dot set current position, day dot get day. So this is what I have with respect to the day. So fine, I will be explaining this in detail. Don't worry as of now, right? So fine, I have the program graphs for month methods. So guys, please observe month dot constructor, month dot set current position, month dot get month, and month dot set month, month dot get month size, month dot, I have boolean dot increment. It's not month dot. Yes. So fine, this is with respect to the month. Moving forward to the last one, that is year. Okay. Observe here. Year dot set current position, year dot constructor, year dot get year, boolean dot increment. So guys, boolean dot is leap year. Okay. This is what I have with respect to the year. So hope you have just got an abstract view about this program graph. Now, guys, let me explain this in detail. Listen to me carefully. I have the program. So guys, so please observe. Let me explain that in the next one. So this is the calendar program. This is the calendar unit. This is the beginning of the program that I have here. So guys, observe from here. This is what you need to understand. Pay a little attention here. Let me explain this. So guys, class tested. Okay, I have a class tested. You all remember. So I have different classes, right? So what is the different classes that I have? Let me show you once again so that you will remember and understand. So guys, observe here, different classes that I have. I'm speaking with respect to the test it. I'm speaking with respect to the test it. And also I have shown you one abstract class called calendar unit. Okay, so this is what I have here. So please observe here the calendar unit. So this is the calendar unit that I have. This is the pseudocode that they have written. All right. So let me start from here. So the class tested. So what is that I have here? They have given the program. Already we have discussed the next date problem, right? So I have explained this line by line. So that's what you need to remember. Go back to the next date problem that I have done. I have explained that line by line. So that's what you need to remember. But the concept here that I'm going to try to explain is how exactly this graph they are trying to map. So that's what I'm trying to explain now for all of you. Guys, observe the line number that I have here. What exactly that I have? Tested. I'm speaking with respect to this. So line number 1, line number 2, line number 3. That's what they are trying to explain here. Tested consists of 3 lines. So what is that I have? So test date. So test date dot increment, test date dot print date. So this is what that I have. 3 messages they will pass. So that's what you need to observe here with respect to tested. So that's what the class that I have in the tested. So guys, responsibility, when it comes to the responsibility of this tested, what exactly it is doing, serves as a test driver by creating a test date object, then requesting the object to increment the date itself, and then finally to print the date a new value. That's what this function is doing, nothing else. That's what you need to remember. Moving forward to the class date. What is that I have? Moving forward to the class date. So please observe what exactly this class is doing. So after that, let me explain this. All right. So please understand, a date object is composed of month, day, and year object. So I have the date object that consists of 3 things. One is day, month, and year object. So fine, a date object is increments itself using the inherited Boolean increment. So please understand, I will show that Boolean increment. Okay, remember this word. So it inherits and it uses the Boolean increment method in a day and month object. You all know that if I have a date like 14th today and I'll ask for the next date, so obviously I have to increment the date to the next date and I have to give. So that's what they are trying to explain here. So now it's very important how exactly this date graph and the program, what class I have that they are trying to map. So please observe here. Guys, you already have observed the tested, so you don't have to worry about it. So we have already discussed. Now it comes to the date dot constructor. Date dot constructor. That's what I'm trying to show you now. Please observe. Date dot constructor has got 4, 5, 6, 7. So that's what you need to remember. So from here, the date dot constructor starts. Sir, why do you call that as a constructor? Because the class name and the function name is same. So we are trying to initialize the values of month, day and year. That's what you need to remember. That's why I will call it as a date dot constructor. In the same way, date dot increment I have. So it starts from line number 8. So please observe the function called increment here. So it starts from the line number 8. So guys, till 18 I have this function which will help me to increment the date is what you need to understand. Then after that I have date dot print date. So guys, I have line number 13. Is it? No, 19 and 20. This will help me to print the date. That's what you need to understand here, right? So that's what you need to remember. Moving forward to the day, I have the class called day. What happens in the class called day? So please observe a responsibility. The day object has private month attribute that the increment method uses to see if the day value can be incremented or set to 1. So that's what we have already discussed. When I have a day, so please remember, can I increment it or can I reset it to 1? So that is what we are trying to do here with respect to with help of get and set methods. So fine, observe here, day dot constructor. So it starts from 21 to 22. So guys, we are initializing it here because day is a class day. Class name is day. Again, we are using the function called day. That's why we call it as a constructor. Why do we use constructor? To initialize the value, whatever I have. So automatically whenever the object is created, that's why we call it as a constructor. All right. So what is the next one that I have? Day dot set day. So if I want to set the day, so guys, it starts from 23, 24, 25, line number 23, 24, 25. That's what we have to understand here. So this is the function that I have to set the day. So fine. Then I have day increment. So if I want to increment the day, guys, please observe. What is that I have? So what is the line number? Please understand. Line number 28. It is not 26. That's what you need to remember. So fine. So here I am using the Boolean increment, which is inherited. So that's what you need to remember. I told you in the back slide. All right. So please understand from 28 to 33. So it will help me to increment the day. So fine. After that, what is that I have? Guys, day dot get day. So fine. I have 26, 27. This will help me to get the day. That's what you need to remember here. So guys, so this is how you will be tracing with respect to the classes, with respect to the graph is what I wanted to explain all of you. I have month and also I have year. Let me explain that for all of you. The next one that I have is month, even in the same, okay, even in the month also, whatever we did with respect to the date and whatever we did with respect to the month, the same thing happens here also, guys. The graphs, whatever I have here. So this speaks about the line number and also whatever I have here. This is the name of the function that I have. So you just have to go through this functions in the class, whatever I have written for the month, okay. So if you just look at the class, whatever we have written with respect to the month, so you will get to know about the program graph. So, but understand the responsibility before you start reading this class is what I would like to tell you with respect to the month. Even for the year also, first you need to understand the responsibility. What is the responsibility that I have with respect to the year? So please observe. In addition to the usual get and set methods, a year object increments itself when the test date is December 31. So obviously, right? So whenever I have the date that is 31, and also month comes to the December, obviously the year will get incremented. That's what you need to remember. And we have also written a class for this year also. Even this class has got these many functions inside this class is what you need to remember. So this is what you need to remember with respect to the 5 different classes with respect to the programs graph is what I would like to tell you, all of you. So this is going to be very important with respect to the exam point of view. Now, the next concept that I have is methods as units. So guys, what exactly that I should remember with respect to the methods as units? This is appropriate only for the larger classes. That's what you need to remember. So with respect to the first point. So fine, what is the next concept? Next point that I have. When it comes to the next concept, so guys, it says that, so it should consist of one designer or one unit practice. Yes, we have discussed this with respect to the different definition with respect to the unit. Yes. So guys, this leads to a single method testing. When I have the single method testing, so it reduces to the unit testing for procedural units. So that's what you need to remember. So what happens when it reduces for a procedural units? So please remember, when it comes to the object-oriented units are typically less complex than the procedural units. So when I have this concept, obviously it demands for the inter-class testing, that is what I will call it as the integration testing. So that's what you need to remember. The highlight is it also requires the integration testing. So fine. So please observe classes as units. When it comes to the classes as units, so please observe in the UML, the de facto standard, that is behavioral model for a class is a stat chart. So whenever I take the class behavioral model, so it is a de facto standard that I have to consider the state chart to understand the behavior of a class. But listen to me carefully. So guys, even the state chart composition is possible only in the extreme simple classes. But when it comes to the complex classes, even the de facto standard behavior model, that is state chart, that will also not work properly for me. So there also it demands the testing complexity shifts. So it demands the integration level testing. That's what you need to remember. So guys, so with this, I conclude this chapter. So hope you have understood. By saying this, let me wind up the session. Thank you.